I'm Anil Kumar, and here is an interesting question which can be solved using trigonometric ratios. Question 14. The flagpole at a school is 10 meter high and casts shadow that is 4 meter long. If school is 28 meter tall, how long is its shadow? Now this particular question can be solved in two different ways. So we can think about similar triangles also. So what I'm doing here is I'm just trying to sketch the situation which could be solved using similar triangles. So let us say this is our flag, right? OF is our flag, which is 10 meter high. So this flag is 10 meters high and it casts a shadow which is 4 meters long. So this is the shadow which is 4 meters. On the other hand, let us say we have the school building which is 28 meters high. So that is the school building. And we need to find how long is this shadow, how long is this. So we need to find that distance. Let's call it D. So that is the situation, correct? Now the question here is this diagram correct? Well, whenever the shadow is being cast, the sun is at particular position, so the angle of depression is going to be same. So it has to be same angle, right? So this angle is same. Let's call this angle as theta for both the situations, right? So since they are all perpendicular to the ground, we have AA, right? And therefore the big triangle is similar to the small triangle. So we can solve this question using similar triangles, right? So using similar triangles, the solution will be, so we are using strategy which is similar triangles. In that case, we know the ratios of the sides. So we know 28 over 10, 8, we can write D also, is equals to 10 over the shadow is 4 meters, correct? So that is how we can use similar triangles and solve. So from here, D is how much? Cross multiply. So we get 28 times 4 equals to 10D, or D is equals to 28 times 4 divided by 10, correct? And now we can use calculator, find the answer. So we have 28 times 4 equals to divide by 10, and it is 56 over something, so it is 11.2. So we get an answer as 11.2. That is one way of doing it, right? So that is using similar triangles. Now we can also solve this using trigonometric ratios. Can you tell me how? We know height and distance problem, that means it is tan theta, right? Opposite over adjacent. So what we can do is we can consider a small triangle. Let me call this as A, this point as B, and this point as C, right? So in triangle AFO, we know opposite side and adjacent side, so we can say tan theta equals to 10 over 4. So from here we can find what theta is. We say theta equals to, theta equals to tan inverse of 10 over 4, correct? So we can use calculator, find the answer. So we do tan inverse, shift, tan inverse, 10 over 4. 10 divided by 4, bracket close, equals to 68.1985. Always use 4 decimal places. 68.198, I'll write 6 because 59, okay? So it's good to use 4 decimal places. So we know theta now. Since we know theta, now we can consider the bigger triangle. The bigger triangle is ABC, right? Now in triangle ABC, theta, the angle is same. So we can say tan theta is equal to 28 over D, right? 28 over D. Since we know the angle, we can say D is equals to cross multiply, right? 28 divided by tan of the angle, which is 68.1986. Okay, so we'll use this calculator once again, and we say 28 divided by tan of 68.1986 equals to, so we get 11.1 11.19, which can be rounded to 11.2. Do you get the idea? So we get the same answer. Do you see that? So both ways we could solve this question, correct? And therefore we can write down our answer as shadow length is 11.2 meters. Remember, whenever you are working with angles, to get accurate answers, you have to use 4 decimal places. That helps. Thank you and all the best.